In this video, we have an example of two absolute value expressions and something that is not in an absolute value inside an equation. We have the absolute value of x plus the absolute value of x plus 3 equals 3. The way we will approach that is we'll look at four different cases, and both expressions being positive, both expressions being negative, one expression being negative, and then the other expression being negative. And I'll run through those. So let's start here with case 1. Case 1, that is both positive. Both of the expressions here inside the absolute value are positive. And that will give us an equation, x plus 3 equals 3. So we'll add the x's and we get 2x equals, we'll subtract the 3 from each side, we get 0, so we have x equals 0. Let's hang on to that solution for a little bit later. Case 2. And in case 2, let's make both of these the opposite. So we have negative x and we have negative x minus 3, the opposite signs of what we see in there. So we'll have the equation negative x minus 3 equals 3. All right, that gives us negative 2x equals 6, which gives us a solution of x equals negative 3. Now ordinarily that would be pretty good, but let's see what happens as we move on here. Case 3. And in case 3, let's just set this expression the opposite sign. So just negative x. So negative x plus 3 equals 3. Well, the x's will cancel out, and the 3's, if we add a negative 3 to each side, the 3's cancel out. And what we get is 0 equals 0. That gives us all real numbers as a solution. To this particular equation, this part of our solution, all real numbers. Now our solution, our final solution, will not be all real numbers, but this is an important piece to this puzzle when we're trying to find the overall solution to this original equation. Okay, the last one, case 4. And in case 4, we will just let the second expression be the opposite sign. So negative x and negative 3. So we have positive x here to start this part, and then minus x minus 3 equals 3. The x's will cancel out, we'll get 0, and we add 3 to each side, we get 0 equals 6. Well, that's no real solution, so we can throw that out. Good. When we have this situation where we have all real numbers as one of the case solutions, what we will have to do is, I think it's easiest to look at it on the number line. We say, well, it could be all of these, but we are going to have to check. So we're going to make our zones here. We have a 0, we have a negative 3, and we have all real numbers. So we have 3 zones. Let's set them up here. Everything less than negative 3, everything in between negative 3 and 0, and including those numbers, and everything greater than 0. And we'll just check a number in there. So let's test when x equals negative 4. That just makes it easy. Let's say x equals negative 4, any number in this zone. If we were to plug that in there, we would get the absolute value of negative 4 plus negative 4 plus 3. Does that equal 3? Well, we get 4 plus 1. That does not equal 3. So this gets an x. That's no good. We could pick a number here, and just to move things along, I can just kind of pick x equals negative 1, and we get negative 1. Let's do this. The absolute value of negative 1 plus the absolute value of negative 1 plus 3, And does that equal 3? Well, we get 1 plus 2. Does that equal 3? Yes, it sure does. So this is good. This gets a check mark, this region. Let's check one more. Let's check a positive one. I don't think it's going to work, but let's check it out. We'll say positive 1, x equals 1. We'll put in a 1. That's the absolute value of 1 plus the absolute value of 1 plus 3. Does that equal 3? I put a question mark saying, does it equal that? We have 1 plus 4 is not equal to 3. So this does not work either, this region. So what we have is just this interval for our solution. I'll give myself just a little more space to write the solution. Our solution then is we're going to be including negative 3. It was equal to negative 3. Including negative 3 and 0. And that's our solution there. We could also write it negative 3 is less than or equal to x is less than or equal to 0. That's another way to write this notation. But that's the solution to this original equation of absolute value of x plus the absolute value of x plus 3 equals 3. I'll bring that back down here so you can see that solution. I hope that helps.